Welcome back, Math 10. Today we are going to look at entire radicals and whole radicals. So now, based off last class, I want you to write a general algebraic formula for division and multiplication of radicals. Now, I'm going to check tomorrow to see if you did this, okay? So let's take a look here. I have a hint. Now remember, if we were adding some numbers together, so if I said a plus a, that's the same as 2a, right? So we kind of want an equation like that, but for division and multiplication of radicals. We might need more than one variable here. That's another hint. So I kind of want to set it up like this. Square root of some variable multiplied by the square root of the variable is equal to what? So look back at your notes from yesterday and see if you could solve that. Pause, write it down, and then when you're ready, come back to me. Okay, so now we're going to use the product of radicals or a quotient of radicals to simplify each of the following. So let's try the first one here. We want the square root of 24. Well, square root of 24 is equal to 4 multiplied by 6. Okay, so if I break this out, that's 4 times 6, right? Now, if I look at this here, that's the same thing as the square root of 4 multiplied by the square root of 6. Okay? Well, what is the square root of 4? That's just going to be 2. Then we have square root of 6. And there we go. That one is done. Let's take a look at my next one, 18. If I break this down, I could have, well, a 2 and a 9. And I'm choosing certain things carefully here. Why did I go with that 9 if I go 3 and 3? So I get square root 2 multiplied by square root 3 multiplied by square root 3, which is the same as square root 2 multiplied by square root 9, which is the same thing as 3 root 2. There's many ways of doing this. There's a faster way that you probably could use, but I'm just showing you how they are so well and easily interchangeable. Let's look at the next one. Well, this could be simplified, can't it? This could be square root of 11 all over square root of 4, because it's division. Now, does that simplify too? Simple. Square root 11 all over 2. And we're done. Okay? So now, I have a different exercise for you. Let's take a look at this here. Okay? So, Mr. Fody has a radical secret. It's very radical. When it comes to simplifying. Can you figure it out? So here I have my radical. It's going to be 720. Okay? Now, this is simplified form, and that there is the not simplified form. So here's a simplified form of the radical 720. What am I doing? How is this related to that? Here's a not simplified form. This is not the same. What am I doing to go from here to there? What am I doing to go from here to there? Well, what is 9 times root 80? Okay? Here's the next one in simplified form. Okay? This is not in simplified form. Okay? This is not equivalent to that. These are equivalent to this. These here are not equivalent to that. Let's take a look at that one. This one here is equivalent to the square root of 720. This one here is not equivalent to the square root of 720. Let's take a look at one more. This one here is equivalent to the square root of 720. This one here is not equivalent to the square root of 720. And we have this here and this here. Okay? So, what is my secret here? Can you figure out my secret? Okay, I'm going to check to see if you're able to figure out what is my secret in this part here. All right? Now, let's take a look at my next question. So how do we convert radicals to mixed radicals? Well, here's my little hint for you. First thing we must do is use our friendly factor tree. So let's go into this here, and I'm going to write it down first. So we want to use our friendly factor tree on 108. So I break this down. I know this is the same thing as, I could divide it by 2, and I could get 54. 54 is 9 multiplied by 6. 3, 3, 2, 3. Okay? Now I look at, any time we're square rooting, we want to know how many couples there are there. Because there's a little tiny 2 there. That means we only could take pairs out of the square root tree. So we're going to find all my pairs. Everybody needs a buddy. So there's 2 2's. So we have a 2. Okay? We have 2 3's. So multiply by 3. Because everything's being multiplied in there, right? And we have, what's left over? This little guy here is left all by himself. So I have square root 3. So it's left with 6 square root 3 is my answer. And that is how we do that. Okay? Now, let's try these ones here. Square root of 50. Well, that's the same as 5 multiplied by 10. Well, I go, that's 2 and 5. I have, what pairs, what couples need there? If you want to leave this house, you need a friend, one friend, because there's 2. It says 2 people to leave the house, so we have 1, 2. 2 could leave. We have 5, and then the 2's left over, because the 2 doesn't have a buddy to leave. Let's look at 45. Well, first factor tree. We want to get 9 and 5. 3 and 3. Well, I need 2 buddies to leave the house, okay? So that's going to be, I have the 3's as buddies, which is 3 square root 5. But also I could have done this the other way, which is square root 9 multiplied by 5, which is same as square root 9 multiplied by square root 5, which is 3 root 5. So there's 2 ways of doing it. The factor tree is nice because it makes sure you get all of the common factors and everything that can be taken out. Let's take a look at 320. I have 10, 32. Here I'm going to have 2 and 5. Here, oops, circle those, there's a prime. Here I'm going to have 2 and 16. Now I'm going to have 8 and 2, 2 and 4, 2 and 2. So I have quite a bit of 2's here. 2's, 2's, and 2's. So we have 320. So I have one pair of 2's. I have another pair of 2's. And another pair of 2's. All those are multiplied together, and I'm left with a 5. That doesn't have a buddy to leave the house. So we look at this, it's 8 root 5 is my answer. And that's it. Okay? Now, how about these ones here? So these are a little bit more tricky. There's a number outside already. So let's try this one. So first, same idea, just going to factor tree. I know 3 could divide that because if I add these all up, that's 12. 12 can be divided by 3. And I divide that by 3, I'm going to get 64. 64 is 8 multiplied by 8. Well, I'm not going to go any farther because I already know I have a pair there. So we have a pair of 8's that can be taken out. So I'm going to have 2 multiplied by 8 root, and what's left over? 3, which is equal to 16 root 3. And that one's done. Let's try my next one. We want 3/4 multiplied by all of that. Okay? The reason I was able to multiply this 2 in is because we're multiplying everything here. So 3/4 multiplied by all that. So 160 can be divided by 10, and we have 16. And that's 4 and 4. 2 and 5. I look at this, I could take out a pair of 4's. So it's 3 over 4 multiplied by 4. Okay? And we're left with, well, 10 in the middle. 2 multiplied by 5. Which gives me a total of, these 4's cancel off, because I go 3 divided by 4 multiplied by 4. That's just going to give me 3. So I'm left with 3 square root 10. Okay? Now my next one here. How can I simplify this one? Well, I look at this. The top can be broken down to just 7. What about the bottom? That is 3 and 3. Okay? So I'm breaking it down that way. So square root 7 all over square root 9. Square root 9 is 3, so that's just 7 all over 3. Square root 7 over 3, or 1 over 3 multiplied by root 7. Okay, so those are all possible answers. Okay, so now, how would we solve a question that has a mixed radical and you want to put it into a whole? So I want you to think about this. Pause the video, come back, and think about this, okay? Now, once you solved it, you're going to be thinking like this. You're going to think that
this is the coolest thing I have ever seen. This is the coolest thing I have ever seen.
Okay? So you're going to be thinking about that. Now, let's try, hopefully you did this part first. If you haven't, pause it and come back. Now let's try these out and convert each to an entire radical. So we're going the opposite direction here. Okay, we're going to convert to an entire radical. So I want to multiply this 2 into the 5. So before, I had to take out this 2 here, means we had to take out 2 2's from the house to put it in front. So we must put in 2 2's multiplying to put it inside the house. So I get 2 multiplied by 2 multiplied by 5, which will end up giving me 4 multiplied by 5, which is going to end up giving me square root of 20. Okay? Let's try the next one. 4 root 7. Well, there's a 4 that was taken out. So that means there's 2 4's taken out of the house. So that's root 7 multiplied by 4 multiplied by 4, which is the same thing as root 7 multiplied by 16, which will give me 70 plus 42, which is 112, root 112, I believe. Okay? Now let's try this last one here. We have 10 root 6. How does that work? So I have to multiply 10 in twice, because we took out 2 10's. So we have square root 6 multiplied by 10 multiplied by 10, which is equal to square root 600. And that's it. Pretty simple, isn't it? Now, here are some real bit more of a pickle questions. Let's try these ones here. So I have 3 over 2 and the square root of 8. So we have to put in both of these. So that means I took out 2 3 over 2's. So we have square root of 8 multiplied by 3 over 2 multiplied by 3 over 2. Now I multiply this in. Both of these, divide that twice, I'm going to be left with 2 multiplied by 3. Multiplied by 3 is going to give me 6. Multiplied by 3 is 18. And that's my answer. All right? Let's take a look at my next one here. We want 0.4, and we're putting that in 2 times. This is a decimal. Oh, decimals are tricky. So we have to go square root 50 multiplied by 0.4 multiplied by 0.4, which will end up giving me, well, this is going to be 50 multiplied by 0.4 is going to be 20. Okay, then we have to multiply this by 0.4. Okay, 20 multiplied by 0.4 is going to give me a total of square root of 8. Now this here could be simplified and brought down into a mixed if we want, but I'm just going to leave it like that. Now here's my last one. We want -5 put in. So let's think of how this one could be done. Well, I'm going to do this one here in a little bit different fashion. Not because of the negative. I'm going to think of it differently. Well, 5 is the same thing as square root of 25, isn't it? And then we want to multiply it by square root of 7. This is just a different method of approaching, which is the same as -7 multiplied by 25. Okay, so I'm going to get 140 plus 35 is going to be negative square root of 175 is my answer. Okay, because 7 times 20 is 140, then 7 times 5 is 25, or 35. Okay, and we add those together. And that's it. All right, so now it says solve for A and B and keep your answer in exact form. So we want to solve here for this side. Okay, my first problem is I do not know that. Okay, or we could say this is x. So we know the Pythagorean theorem is c squared is equal to a squared plus b squared. This here is my hypotenuse, so that is just going to be a side. So I'm going to have x is equal to c squared minus b squared. Okay? So I'm going to have 12 squared minus 8 squared. And I square root that. So that's going to give me the square root of 144 minus 64. Okay? And we continue that. That's going to give me square root of 80. So this is square root of 80. Now we want to find AB. AB is a hypotenuse. So we're going to have to go c squared, or AB squared is equal to a squared plus b squared. Okay? So we're going to have 6 times 6 squared plus, and we have square root 80 squared. All right? Well, if I square the square root of something, that would be like square root of 80 is something, then we square that number. It's going to be the same. It's going to be that number, right? Just get rid of it. Like, square root of 25 is 5. Then square it's 25, so it's really just canceling out the square root. So I'm going to have 36 plus 80 square root, and that's just going to give me AB. Because basically I had AB squared here, and I square root both sides to get rid of that square. So this is going to end up giving me 116 square root of 116. Alright? Now I have to figure out, and we want it in exact form. So this here is an exact form. If I want, I could try and put in mixed form. So if I divide that by 2, this is going to be the same as 58 and 2. Okay? And I could divide this by 2. If I divide this by 2, it's going to be the same thing as 2, and we have 29, and then that's going to be it. So it's going to be the same as 2, we have 2 pairs of 2's, root 29. And that is the best we could do for our answer. Okay? So it's this or this. I'll pretty much accept both of those answers. So good luck. Hopefully you understood everything, and good luck as you work on this tomorrow. See you tomorrow.